Okay, ladies and gentlemen, welcome back. In this video, we're going to be looking at a couple examples of projectile motion situations. And in these two examples for this video, we're going to keep the initial launch of the projectiles horizontal. So in this first example, we have a ball is thrown horizontally from a third-story window that is 12 meters above the ground. If the ball lands 3.5 meters away from the building, how fast was the throw? You may be tempted to jump right into it and start sketching things. Normally that would be good, but I want to show you something. If you have a question like this and you're allowed to sketch things out or write things down, well, underline some key words and identify some information that's helpful. Horizontally thrown means that your initial velocity in the y direction is 0, and this 12 meters above the ground is a displacement in the y direction. This 3.5 meters away from the building is a displacement in the x direction. How fast was the throw? How fast is an initial velocity in the x direction? So that's what we've got to find. So some quick notes like that. Now we can start a sketch to get things going. And there's going to be a window. Let's say we got the window open, even though that doesn't look like it. And a ball is thrown horizontally initially. And the ball will follow a parabolic trajectory and land on the ground somewhere. And in fact, if we have our building here, right? What we know is that it lands 3.5 meters away from the building, and we know that the window is 12 meters above the ground. And so in my diagram, there's really not much else to label. Well, I do have an unknown here. I have an initial velocity in the x direction, and that's what I want to find. I don't know that guy yet. So the next step is I want to list information, and there's actually quite a few things that I am able to list. Knowns, and I also have some unknowns in here as well. So one of the first things I'd like to do is to actually list the thing I want to find first, right? And just highlight that or circle that somehow to remind myself that's my goal. That's what I'm working toward right there. I know some of the information. Since it's thrown horizontally, my initial velocity in the y direction is 0. I also know that I have a displacement in the x direction of 3.5 meters. I have a displacement in the y direction of negative 12 meters, and that negative sign is important. It's starting here at the top and it's going to move vertically 12 meters downward, so I want to keep that negative sign there. I know some information about acceleration. In the x direction there is no acceleration. Velocity in the x direction is constant. In the y direction, this is going to be equal to negative g, which means it's equal to negative 9.8 meters per second squared. And one final thing is time. Now I am not given a time. That's also an unknown. I don't know if I'll need it initially. It's possible though, because time is sort of universally used in both the horizontal and the vertical. It applies to both. So I'm going to look at this, the goal, and I'm going to say to myself, well, the goal is a velocity, but it's a horizontal velocity. So I might say to myself, I want to start by looking at some horizontal information and see what I can work out, if there's anything I can work out. So to calculate the initial velocity in the x direction, well, a velocity is just a displacement divided by a time. I need displacement in the x direction divided by the time. The problem here is I have an unknown there, that's my goal, but I also have an unknown there. Two unknowns in a single equation, I really can't solve it. So I need to find time and then use this equation once I know it. But I'm going to find the time using vertical information. And so that's what's going to happen here next. I have a final velocity in the y direction. I'm looking at possible equations here. This is equal to an initial velocity in the y direction minus g times t. So what's my issue here? I know that value, it's 0, and I know that one. Can I solve for time? Well, the problem is I also don't know this one. So this is an unknown, and that's an unknown. Again, I have two unknowns. Can't use that equation. So let me look at something else. I'm basically kind of going down a list of equations in my notes or in the textbook, and I can end up at one of them that's going to work. So displacement in the y direction is my initial velocity in the y direction times time minus 1/2 gt squared. So I have to look at this and ask myself, do I have everything I need? Do I have my displacement in the y direction? I sure do. Check mark. My initial velocity in the y direction, I know it. In fact, it's 0. Check mark. And since it's 0, actually this whole term goes away. It disappears to 0, right? I know g, that's 9.8. I have my one unknown. This looks like my winner. Yep, get to use that equation. So instead of trying to cram this into the bottom corner of the page, let me go to another page here. And I'm simply going to continue this work. I'm going to rewrite my equation a little cleaner. In the y direction. Remember, this term is now 0, so I'm not going to bother rewriting it. And it's equal to the rest of this, negative 1/2 g t squared. And t is the thing I'm looking for, so I'm going to isolate t. And when you do this, you end up getting negative 2 delta d in the y direction divided by g. Now, if you're not sure how I get from this first equation here to this one, then come and talk to me real quick before after school. I can show it to you. It's not a big deal. It's just some rearranging of some variables in the equation. So here we go. I know my delta d in the y direction, and I know g, so I can figure this guy out. Substitute some numbers. I get negative 2 times, what's my delta d in the y direction? Negative 12. And now you start to see why it's important to keep that minus sign there to understand that I need that. Negative 12 meters divided by g, and g is a 9.8 meters per second squared. So what's nice about this is if I keep all my minus signs organized, then I do not end up with a negative under the radical, and everything works out. And when I do this and solve those numbers, I get a time of 1.6 seconds. A little bit of rounding to get this number. So if you get 1.5-ish, then you're there. You got it. And this is not the answer I'm looking for. Remember, I need time in this equation to find my initial velocity in the x direction. So I have one more step to perform here. And so I go back to looking at horizontal information. And that equation for the initial velocity in the x direction is displacement in the x direction divided by time. That's easy enough. And now I know that that's a 3.5 meters. And my time now, I know, is 1.6 seconds. And when I do that math, 1875, that's way too many digits in the answer, so this is rounded off to 2.2 meters per second. Box around my final answer, and I'm good to go. That is how fast the initial throw had to be. Right there, that's my answer. That's how fast that throw had to be in order for this ball to land 3.5 meters away from the building. If it's thrown from a window that is 12 meters off the ground. So that's what we have going on. Sorry if that was out of view. There we go. One more example for you. This is page 3 of the information here in this video. Here's what this one says, and just in case it might be a little difficult to read. A ball is kicked horizontally off a cliff and lands some distance away. When it lands, it is traveling at 28.1 meters per second at an angle of 41 degrees from the horizontal. How fast was the ball going just after it was kicked? And how high is the cliff? So we got to tackle this. This is going to it's going to be a good one. So I'm going to sketch the situation first. I have a cliff. All right, and a ball is kicked off the cliff horizontally, and we do not know that initial velocity, right? Initial velocity in the x direction is an unknown. The initial velocity in the y direction is 0. It's kicked horizontally, and the ball will follow this parabolic shaped trajectory, right? But here's the kicker. When it lands, we are told something about the velocity and the angle upon landing. So I have a velocity here right before it hits, and this is 28.1 meters per second, and I also have an angle there, angle of 41 degrees, right? Okay. Now, what am I asked for? I need to recognize this. How fast was the ball going just after it was kicked? How fast? That's the velocity. So here's one of the things I'm asked for. And also, how high was the cliff? I need to try to find delta D in the y direction. That is the height of the cliff. Right there. Okay. Well, what I have to look at here is, first of all, one of the things about projectile motion problems is you need to separate the horizontal and vertical information. But when I look at this, I don't have that separated. It's combined. So I need to sort of figure that out. I'm going to redraw a velocity vector here, and this is 28.1 meters per second. And the thing about this is I need to understand that velocity is made up of two components. There is a vertical component and a horizontal component. So this guy is, now these are final velocities. This is right before it hits, so there's a final in the x direction, and this is a final velocity in the y direction. And I know one more thing about this, and that is the angle. This angle right here is 41 degrees. So I can look at that, and I have a right triangle. I have this right angle here, and so this is a hypotenuse, and with one side like the hypotenuse and the angle, I can figure out these two sides. The final velocity in the x direction is equal to hypotenuse times cosine of that angle, because this component is adjacent to that angle. So I have 28.1 meters per second times the cosine of 41 degrees. And when I work that math out, that's going to get me 21.2 meters per second. And so now, correspondingly, final velocity in the y direction. Since the y component here is opposite of that angle, I need to use the sine function. So I will have 28.1 meters per second times the sine of 41 degrees. And when I work that out, I get negative 18.4 meters per second. Now, whoa, you're saying to yourself, wait a minute, Woods, where'd the negative come from? And it doesn't show up when you do the math, but you have to remember that guy. It's important. And the reason is, look at this component. This vertical component must be in the downward direction. I must have a negative value there in that velocity. So it's not just blindly going through math and getting an answer. I must be thinking about the real situation. Real situation is there's downward motion along with horizontal motion. And downward would be negative direction in the y direction. Okay, so we got that. So actually, believe it or not, we've already answered the first question. And the reason is this. The first question, how fast was the ball going just after it was kicked? So it's this velocity here. The thing about it is that velocity horizontally is the same beginning and ending. That doesn't change. And it doesn't change because there's no forces acting horizontally. There's no acceleration horizontally. So the final velocity in the next direction is going to equal the initial velocity in the next direction. Those two vectors are horizontal, and it would be the same before and after. So the initial velocity in the next direction, I already have the final 21.2. That means I already have the initial. There's the first answer I need. So the second answer, I have to look at how high the cliff is, or I'll try to figure that out. So I have to look at some vertical information here. How high is the cliff? That really is my delta d in the y direction. And that's what I want to know. Well, is there other information? So I'm just going to create a list of information here. So it's kind of like my knowns and unknown. Well, I know that my initial velocity in the y direction is 0. I know that my acceleration in the y direction is negative g. So that's negative 9.8 meters per second squared. I do not know time. That is an unknown in this situation. I do know my final velocity. I just worked that out. Final velocity in the y direction. Negative 18.4 meters per second. And so I have a list of known and unknown information. I have to ask myself, is there a way to get to the answer to this guy from what I have? And there's a couple ways of going about this. The most direct route, if you can see this, is, well, I have a initial velocity, I have a final velocity, I have an acceleration, and I want a displacement. So the most direct route is actually going to be this equation. Final velocity squared, and this is in the y direction, equals initial velocity squared minus 2g delta d in the y direction. So this equation is a little bit different than what you're used to, only because it used to be plus 2 times a. And a gets replaced by negative g, by minus g. A is negative g. So there's the negative sign associated with g. It's right here in the equation now. So what I need to do is simply rearrange this equation and solve for this guy. That's my unknown, that's my goal. So delta d in the y direction. And I'm going to end up with final velocity in the y direction squared minus initial velocity in the y direction squared divided by 2g, right? Except I have a minus sign here, so there's a negative sign that I must float right there. And you're going to see why it's important to keep that. Don't lose that. So delta d in the y direction. I can plug numbers in. My final velocity here is an 18.4 meters per second in the y direction. My initial velocity, that is squared. Don't lose track of your exponents. Oh my goodness, I almost just did that. My initial velocity in the y direction was 0. And I have times divided by negative 2 times g, which is 9.8. meters per second squared. Okay. Looks like at this point I just need a calculator. And so I have this going on. Now check this out before I give an answer. This is going to be a positive value, and I'm going to take away 0. So I have a positive on top. That's a positive, that's a positive. And that's a negative, so I'll have a negative on the bottom. So I should, from the math, I should expect a negative answer. So, negative answer. Does a negative answer make sense here? And the answer is yes. If you think again about what's going on. Then the ball gets kicked off the cliff, and it's going to fall vertically a certain distance, and it's going downward. I actually drew this arrow in the wrong way. Erase, erase. So I need to get a negative value for my displacement in the y direction. And the value that I get, turns out, is negative 17.3 meters. So what's the answer to the question? And this is, you're going to think this is kind of picky, but yes, it matters. How high was the cliff? How high was the cliff? That is the question, and that's the way it's worded. To answer this question, do I provide this number, a negative 17.3? No. Because you don't measure the cliff from the top down. You measure the cliff as a positive number from the bottom up. But it's the same value. The cliff is 17.3 meters high. That is the answer I provide based on the math that I did. So we looked at this and we figured out from the final velocity and angle upon landing at the bottom. We figured out how fast it was going initially when it was kicked. We also figured out how high the cliff was, this vertical distance right here. And that math is shown right here. Thanks for watching. I'll see you next time.